Hi everyone, today we're going to analyze another type of steady flow energy device, which is a throttle. So let's get started. This is a homework problem, and a lot of people think it's a little bit challenging, so we're going to go through this step by step. So part A, water exits a boiler at a pressure of 18 megapascal. So let's start highlighting important information. And the temperature is 640. If the throttle inflow pipe has a diameter of 0.4 meter and a velocity of 20 meters per second, what is the mass flow rate of the water through the throttle? So first of all, old tradition, we're going to put our assumptions first. We're going to assume first it's steady flow. And also, since it's a throttle, so Q dot is equal to W dot is equal to 0. So there's no heat, there's no work. And also, the change in kinetic energy and the change in potential energy are negligible. So these are zeros too. Okay, now with that, let's continue with the first one. So it says, what's the mass flow rate of the water? So if you remember, mass flow rate is actually equal to rho V A. So this V is not volume, it's velocity. So here we know the area because we know the diameter, we can calculate that. And we also know the velocity, which is 20 meters per second. But the only thing that we don't know is the density rho. So we need to understand the phase at this point. So right now we're at P equals to 18 megapascal, and this T 640K, this T is big. Let's just say this is T1. So T1 is bigger than T saturation. So that tells us right now the phase is vapor. So if you go to table D.3T, you can find that the density at this point is 100 kilogram per meter cubed. Okay, so now we have everything to solve for our mass flow rate, which is this equation here. Okay, so mass flow rate is the density, which is 110, times the velocity, which is 20, and the area is just, so this is diameter, so we need to divide that by 2 first. So that's our radius squared, and then times pi. So if we calculate that, we will get 276.46 kilogram per second. So this is for part A.